And then lastly, we have our chi-squared test statistic. So once we've said that, yes, we've obtained a random sample, our expected value is at least 5, and then we can calculate our degrees of freedom using k minus 1, we are able to use this formula here. So this basically is a summation, like we noted before. And so chi-square is going to be equal to our observed values minus the expected values. So that f sub of e is the expected, and then we subtract them and square that quantity, so that's where we get the chi-square, and then we divide by the expected value. And then we just keep adding for every term in our table or whatever we're looking at. So that's the formula. So let's go ahead and put that formula to use. So looking at this example, we see Jep is taking a 100 question multiple choice test where the answer choices are A, B, C, and D. So here, he expects that the distribution of answer choices is skewed where there are more C's than other answer choices. And then we have our alpha level of 0.01. So I want to take a look at why this is a chi-square test, and even though it does say chi-square, how would we know if it didn't? So when I look at this, I see that, yes, we're taking 100 multiple choice tests, so this is probably going to be my n. And then I don't have any other numbers given to me. So I don't have a mean. I don't have proportions given to me. I do have this table, and I do see that it says observed. So that is a good indication that we're looking at chi-squared as well. And then I'm looking at a category here, answer choices. And specifically, there are 4 categories. So I'm going to let k equal 4. We have A, B, C, and D. So once I've decided that, yes, this is chi-square, specifically this is going to be the goodness of fit, since we're only dealing with one type of category, answer choices, we're going to go ahead and create our hypotheses. So our HO is always going to be the observed is equal to the expected value. So again, we're testing for essentially equality here. So that's always going to be our null. Our alternate is always going to be the observed is not equal to the expected. So I know in the problem it says Jep suspects that there are more C's than any other answer choice, but essentially what he's saying is that the observed value, the number of C's, is not going to be equal to what we would expect to see. So that's just how we write that here. So that's our first step. Our second step is the conditions. So I know it doesn't say random here, but let's just assume for the sake of doing the problem. And then we're going to determine the count. So looking at the observed values, we see that there are 20 A's, 20 B's, 35 C's, and 25 D's. So the observed values here are definitely going to be greater than or equal to 5. All of them are larger than 20. So we're good there. That's our normal condition. And then lastly, independence. We have our sample size over the population. So that's supposed to be infinity. So if our n value here is 100, and let's say that there are infinite multiple choice answers, then that's just going to say, yes, we are independent. So we're good to go there. Our third step we know is to calculate the test statistics. So we have chi-square is equal to the observed minus the expected over the expected, and that numerator is squared, just the numerator. So here I need to do this, and this is a summation, so I need to do this for every single answer choice. So the observed for A is 20 minus, and then our expected. We can see the expected isn't given to us, so we need to think of this logically. Our expected would be essentially the percent of times we would see each answer choice. So if we have 4 answer choices, we would expect that 25%, write that here, 25% of the time we're going to get each answer choice. So 25% of my n is going to be just 25. So I would expect 25 answer choices. And again, this is a quality. So we would expect that each answer choice has an equal distribution. So that's why we can just say 25%. And then for B, we have the same quantity. And then C, we have 35 answer choices observed minus the expected 25. And then lastly, this term is going to equal out to 0, but that's okay. And so if we calculate this out, we would get our chi-square is equal to 6. Lastly, we need our degrees of freedom to get our p-value, and this again is our k minus 1, which is equal to 3 here. So these are the two values that I'm going to need to find my p-value. So next, I need to look at my chi-square table. So go ahead and take that out so that you can follow along with me. It's in the back of your Barron's or it's on Google Classroom. So go ahead and take that out.